This is the demo of cross-cloud queries presented to you by Google Cloud. Cross-cloud queries enable users to run a single BigQuery query that can seamlessly join data across multiple regions using SQL join or union operations. Cross-cloud queries are executed in a GCP region, and the remote region must be an Omni region, AWS or Azure. Let's take a look at the set of tables that we will be using for our demo. This is a subset of GPCH 100 gigabytes dataset, and the tables that we will be using are orders, line item, and customers. And these three tables are all in different clouds. In AWS, we have an orders table. It's located in the US East 1 region of AWS. It's a set of Parquet files on an Amazon S3 storage. Let's query its size. So the table has about 2.2 million rows. The line item table is stored in the Azure region, and it's a set of Parquet files on Azure Blob Storage. And this table has $600 million rows. The customers table it has just 2 rows, customer key and country, and it's a managed Google Cloud table in US region, and it has about 1.9 million rows. The last table that we will be using is a subset of orders for 1998. It is also a managed table in the US region and has a little bit more than 100,000 rows. Let's find orders for specific period for 1997 and include some custom information in our report. Instead of just loading the data from AWS and then joining it with customers, we can all do in the single SQL query. Here we join customers table from US region and orders table from AWS region, filtering it additionally by date and by the order priority. And the 4 columns that we return, 2 of them are from orders table from AWS and 2 are from customers table from the US region. If we look at the execution graph, we can see that out of 2.2 million rows in the orders table, only about 70,000 rows have been returned. This is due to additional filtering applied in this query, that this filter is pushed down to the remote region, and only the rows that satisfy this filter are being loaded from AWS into GCP to run the final join. Let us try to compute the aggregated query using computers turning the number of orders per customer's country. The query will be almost identical to the one that we ran before, except that we group the data, the result set by country, and we compute the number of orders in each country. Only 6 rows have been returned, but when we look at the execution graph, we can see that all 70,000 rows have still been loaded from AWS region. And this is because the aggregation operation is not yet being pushed down to the remote region, and this is something that will be addressed in the subsequent releases. So the care must be taken to make sure that you load only the rows that you need and only the columns that you need to reduce the volume of data transfer. What if we additionally want to aggregate the data by shipping mode? This information is not available in orders table, but it can be found in the line item table. However, this table is in Azure, so we will have to join Google Cloud, Amazon, and Azure tables all in the same query. And this is of course possible. So we have a customers table in US region, we have Amazon table orders in AWS region, and we have line item table in the Azure region, all joined in one single SQL query. As you see, we have results grouped by country, by line item ship mode, and we have a number of our items returned. If we look at the execution graph, we see that the joins, first we load orders table, we join with customers, and then we load Azure line item table to join it all together, and then aggregation is applied in GCP. The query, the cross-cloud query, does not necessarily must be a join table. It can be also a union, intersect, or except. And let's demonstrate it by combining orders for different years. And the orders from 1998 will be loading from the US table, and orders for 1997 will be loading from Amazon. So here we have two portions of this query. First, we load Amazon orders for 1997, and we load GCP orders for 1998 from our table that we already have in GCP. And you see that in our results set, we have rows both for 1997 and for 1998, because it's sorted by the total price standing, not by date. In general, Omni external tables and GCP tables can be seamlessly combined in a cross-cloud query of any complexity. For example, we can use Omni tables in CTEs or subqueries as any other GCP tables. Let us demonstrate it by finding the customer countries with the most urgent orders in 1997 using subqueries. Here we load customer keys from orders table in a subquery and then filter the customers table by this subquery. Again, only 6 rows are returned by the number of countries, and it works seamlessly. Cross-cloud queries can also be used in some DDL tables, DDL queries. For example, create table as select, and DML queries such as insert, update, and delete to provide capabilities similar to ETL, but using pure SQL. Let us load the archived urgent US orders for 1997 into a new GCP table, urgent orders 1997. So here we are creating a new table in the US region, and the source of this table will be the join of data between US query and US table and Amazon orders table. The source query is the same as we used before, but the results have been put into the target table in the US region. So the statement created a new table. Here it is. It has only 20,000 rows in the US region, and it's and it has the information that we requested for our specific country. we load data only for US here. The same way as we can create table, we can also insert data into already created table. So let's append the urgent UK orders to the same table that we just created. And we can do this here. And we change the country to UK. And let's run our table. As you can see, some 6,000 rows have been appended to our urgent orders. And when we select country, we can see that now in our table we have both UK and US orders. Cross-cloud queries allow combining GCP tables and Omni external tables from the foreign clouds, such as AWS or Azure or both, in a single SQL statement. This is a capability that is unique to Google Cloud. Thank you.